Copilot Analyst was released last year, and just like with all things AI, things are evolving relatively quickly, but there are some potential shortcomings of this particular approach. Okay, today I'm here to talk about talking to your database, building natural language data analysts. And the pattern that I'll be presenting today will be in the context of data analysts, and it's a series of problems which I've had to solve over this year and last year. And it's a very kind of common theme I've encountered in some cases. Yeah, not just working with SQL and classic data, but working with APIs and legacy applications and a whole lot of other things. So the pattern that I'll be outlining here tonight is going to be focused on data analysts, but you should be able to extrapolate from here and be able to apply it in different contexts. And so the question is essentially this, is what if anyone could query your database in plain English? And so the thing is, it's something like, show me our top 10 customers by revenue this quarter, but there are also other more complicated examples you can get. So the use case here is not everybody is familiar with SQL. Not everybody who's going to be using or wanting to pull data from your database is necessarily a data analyst or a developer able to access this data. But more specifically, they're going to be often business users, and they may not be interacting with this through your equivalent of SQL Studio or equivalent type environment. And instead, the framing for this was people wanting to interact with their business data using chat, not chat within an application, but you can imagine something such as within Teams or Slack. And probably the key differentiator for this was as opposed to opening up something such as Claude Code or working directly through a web portal or using something such as Microsoft Copilot Analyst, having something which was deeply embedded within their environment. And so in this particular use case, we're dealing with potentially hundreds of different users who aren't familiar with SQL, who are wanting to try and draw out these insights. And yes, they want to be able to surface these queries and display them visually. So Copilot Analyst was released last year, and just like with all things AI, things are evolving relatively quickly. This screenshot here was from the first release there, and the idea was someone would enter a particular question, they would upload a single file, such as an Excel spreadsheet or the like, and ask some questions of that data, and then you have these kind of three different modes at the bottom here in terms of what type of information do we want to source from there. Are we after visuals? Are we after something else? And it was quite a promising technology, and it's evolved since, and it's been integrated into Microsoft products even further. But there are some potential shortcomings of this particular approach. And so the thing is we've got some things here which is fairly good. It's now integrated in Excel. You've got this ability to kind of use Copilot with it. You've got support for TSQL. It's got some support for natural databases here, and there's also got this concept of being able to swap between the deep thinking models and some of the kind of lighter weight models. Thing that it doesn't do, of course, is it's limited to the Microsoft ecosystem, and there's nothing wrong if you're working in the Microsoft space, but sometimes you'll be running into some of these rough edges there. So whether or not you're working in Fabric, unfortunately, the thing is because there's no business context typically stored against this, a lot of the queries that you ask are going to have to be somewhat generic. And what I mean by this is based on how you've defined your database in the schema, and we all know this, they don't necessarily translate into a ubiquitous language that the business is familiar with. They might be using terms that the developers are familiar with, or column 1, column 2, column 3. There's work which is involved in terms of translating that data representation to something that the business is aware of. So something like you're getting this kind of impedance mismatch there. So there's also some concerns around that. And as far as Microsoft goes, depending on how deeply you're involved in the AI space there's things around kind of limits and licensing for this as well, when you might be just after some kind of simple queries. And the thing is as I stated before about the schema, that often has somewhat generic schema logic there. So yeah, we can answer separate questions. So analyze the spreadsheets for me, whereas what I'm actually looking to do for this is to be able to query a live database in plain English. So, okay, so why do you want to build your own? So for this, we've got complete control over the logic. We get domain-specific reasoning, which is what doesn't come out of the box when you're using something like Data Analyst and some of these other tools. And what I mean by domain-specific reasoning is some of these things, like despite what I said about ubiquitous language, there's other kind of terminology in terms of things which only the business are aware of, or particularly useful in a sales context, like saying, okay, what is a high-value customer? Well, a high-value customer is something which is defined with more than 10,000 revenue in a month, for example, depending on business context, of course. And a lot of these things don't necessarily translate in terms of what's represented in your database schema. We've got a couple of other things here as well. We can actually start stringing together workflows that can become more deterministic. And we've also got the ability to integrate our own tools rather than just relying on what comes out of the box for a Copilot or another alternative there. The other thing, of course, is there's no over-permissioning. So one of the classic problems that you have in working with any of these ecosystems is basically this concept of governance. And one of the things that people are discovering as AI is rolled out across the enterprise is there's often a lot of work involved in terms of making sure that everyone's got the right permissions. And when it comes to talking to databases, depending on the size of an organization, there can be hundreds of different databases working there. They haven't really been designed to be directly user serviceable as well. And there's associated drawbacks with that. And you've also got the thing in terms of when you're actually building your own, you've got the ability to choose your particular model, which I can potentially demonstrate later tonight, or basically have full control of where your data is residing. So rather than being necessarily just sitting in Azure and being processed by GPT Global or whatever else, or however they've got that configured, you can have this kind of degree of security there. And the other thing, of course, there is you've got performance cost optimization. You've got a good idea of what your costs are. There's no capacity throttling as well. So you're not kind of limited by the number of seats or licenses that you've got by this. It's pretty much determined in terms of how you put this together. So I guess probably the general statement is something like Microsoft Copilot is a great generalist. It's great at solving these kind of high-level problems, individual productivity. But what we're looking at here is actually a specialist, which is quite familiar with the domain that you're working with. So how do we go about this? And essentially, it's a relatively simple pipeline that we do to kind of achieve this. And this is one of these things that people have been working in the space for a little while. It'll be interesting to see that RAG actually pops up in here. And so the thing is basically we've got a user question that's coming in. We've got some sort of RAG retrieval going in the background. And when we're using that RAG retrieval, we're not talking about ingesting hundreds of PDFs or wiki documentation or documentation off the internet. We're actually talking about retrieving information which is particularly relevant to this particular domain. And I'll go into that in a little bit more detail. We've got some sort of process where the large language model generates the SQL. Then we've got some sort of area where the SQL is executed in a secure environment. And then finally, we've got this thing where we're not just returning, a table, but we may be returning a plot, a chart, whatever that may look like. And so the idea is each relatively simple. They can be tested in isolation. There's no framework required to do this, but of course, you're welcome to use a framework to go ahead and do this. So once again, with a lot of these things, it can be worth building it from the ground up or going ahead and taking an agentic framework such as Microsoft Agentic Framework or LangChain or whatever may be your choice here. But there's no dependency on any of that to go ahead and implement this. And the idea is just with all things, when you're working with AI or putting together an AI-based application, it's best to start off with the simplest thing first. In some cases, your use case won't warrant AI. In this case, of course, since we work with natural language processing, we're not necessarily just going to be able to have to use embeddings, but we're going to have to understand user intent. So we're then going down this route of using a large language model to process those requests. So the first step here, and this is where we kind of deal with RAG, etc., is there's kind of three different components that we need to contribute to create a meaningful results based on the queries that we're receiving from the users. So as an example, it's a little bit of an unfair comparison, but like, for example, a classic kind of AI data analyst situation, a lot of this context is missing. You're going to either have to do that through context engineering, basically going ahead and saying, okay, this is what I want in the prompt, and these are the specific details that you're not aware of. And you've got this thing where it's a simple, essentially a memory like a goldfish. Whereas in this, we're taking a grounded approach to go ahead and provide reliable outputs. And there's pretty much three steps here. The first one, of course, is large language models have been around for some time now. And one of the things that they're really good at, of course, is understanding common specific languages. So in this case, we're talking about data definition language for SQL. This is well understood by large language models and some of the things which went in there earlier on. And so the first part, to give it awareness of the database, you're feeding in essentially the schema of the database. And I'll just do a small kind of takeaway here. The context of this is for data analysis as opposed to actually performing mutations on the database, etc., which is a different pattern. You can take this approach to go ahead and achieve it, but it's a little bit more advanced for what I'll be covering tonight. The second part, of course, is kind of covering these things which I was talking about before, in terms of, okay, what your different definitions are for the business. And once again, this is not necessarily represented in your database. And also, depending on if you're just working within a single organization or doing it as a SaaS across hundreds of clients or whatever, they may be using different terms for what they refer to these particular entities with. So no matter how good your modeling is, there's always going to be some variance there. And so you want to have these kind of custom things where for one particular person, $10,000 a month might be considered a high value customer. For another one, it could be considered $100,000, another one for $1 million or whatever else. And this kind of information is not stored in your database, so it warrants specific domain knowledge. And then furthermore, so once you've coupled the schema, which the LLM can understand quite well, once you've got your domain knowledge there as well, so it kind of grounds that schema, then you've kind of got the third part and saying, okay, well, despite having the schema and what these individual definitions mean, you're going to need a third component, which is all part of fundamental good prompting, is providing some examples. And so in this case, we've come up with a couple of Q&A examples and saying, okay, I want to issue a particular query. What is required to that? What would the actual query look like to go ahead and fulfill that need? And I'll go into this in a little bit more depth, but in short, this is where your RAG retrieval comes in. So this is all stored within a vector database. And so the idea is basically all three of these are stored in essentially separate collections or whatever kind of, or indexes, depending on what kind of topology that you're working with there. And by using these, every time a user query is coming in, then it's going to be using a combination of saying, okay, this is the schema. These are the terms that I'm familiar with based on what the user request has said. So the user's referring to OTIP or high value customers or whatever else, so I know what that is. And then here's some sample queries that I've had in the past which have matched similar to such queries. So the thing is, it's not that you're always going to get an exact match, often far from it. But the thing is as you can imagine, a big part of this is the grounding process is determining what your definitions are, determining what your examples are, and of course, providing the scheme, which is a relatively trivial exercise since that's a deterministic system. The second part of this, of course, is how do we go ahead and create these deterministic queries? And essentially, we've got a system prompt here, which pretty much outlines what I said before. So essentially, you've got the thing in terms of, you've got your prompt indicating, okay, we want to kind of generate SQL based on the particular user query. And then we've got, of course, it's a templated prompt, which is using results from that vector query based on what the user issued. So you've got the user issuing the query, you're finding the relevant domain context based on the terms that they use within there. And then you've got some parts related to what the schema is and going ahead and pushing that through. So as you can see here, so you've got that first part. And then the other part, of course, is how do we pass through those few short examples, and they can be appended to the conversation or appended within the query itself, depending on what level that you're working with, and saying, okay, a user historically asked for this. This was a result. This is the deterministic result, which provided the right thing in the past. And we can kind of embed that as part of the context engineering. And so, yeah, there's a kind of a multiple kind of step process here. And so basically we kind of build the message log where we're saying, okay, we've got those kind of samples, whereas the user sent forth the request. What was the thing, what was the resulting query look like, appending that to that, and then kind of building this up over time. And so, as you can imagine, we've done some context engineering, we've got some examples, we've got the domain knowledge, we've also got the schema, so we're really kind of setting us up for success. And we know some of our examples definitely have worked because they're curated ones that we put together ourselves. And of course, the next step, of course, is to go ahead and extract and validate the SQL. So the thing is basically, depending on how you framed it, you can, of course, so for example, if you're using the standard responses library or using something from Anthropic, Anthropic also have structured data now, you can go ahead and structure this differently so you're not actually relying on this kind of particular format here where we've got text and then the kind of SQL embedded with it. So some of these practices you can, depending on the particular environment that you're working with, if you've got kind of structured output, which is very, very much standard in a lot of environments now, you can bypass some of this here around the kind of raw LLM response. And the point is being able to kind of extract that from typically a structured type response here. But once again, depending on what environment that you're working with, maybe you don't have that kind of flexibility, in terms of which case you're going to have kind of like a two-step process. And you'll always be performing the second step. So essentially the first one is, of course, to make sure you can extract the SQL from the response. So they'll often be just via structured data. So that's quite easy these days. And then the second part, of course, is, okay, is the SQL that's been returned valid or not? Okay, so that's the general workflow in terms of how you ground the model, provide the necessary data, and then go through and get it to answer your question. But you might, when you're having a look at this, see some potential flaws here. And the thing is we need to make it smarter, because the thing is they've got a couple of themes with ML and AI in general. Is a couple of things in terms of, one thing is in terms of how the users are using system, that will evolve over time. The expectations that they have of the model, the system will vary over time, and you can't think of necessarily everything up front in that regard. You've got kind of drift in terms of what the model that you're working, the drift in terms of how users are actually interacting with the system. And so we need to somehow kind of dynamically update this while as people use it and improve over time. Once again, you'll be in a most fortunate position to think of every possible permutation that a user is going to come up with. It's one of those intractable type problems. That's the wonderful things about natural language, as opposed to classic structured web-based application calls. And so what you look at this is essentially, there's kind of a number of steps here. And so what you want to do is, based on the input that the user provided and the output that the large language model provided, you need to kind of make a decision in terms of, okay, what's the user asking us to do? Is the user asking a direct request and I'm trying to service that and not having much luck with that? Or is the user imparting some additional knowledge? So the thing is it might have been a year ago or 2 years ago that a high-value customer was considered $10,000 a month. With inflation and whatever other thing for their economic situation may be, it may actually just be 5,000 now, or might actually be 100,000. Bit hard to tell. The point is these things will kind of change over time. And so the thing is you've kind of got this thing where you want to go through, and for each question and response that you're getting from the system, you need to kind of work out, okay, is this something that needs to be persisted within the vector database to kind of build upon that particular store there? And so a lot of this is fairly simple in terms of how you actually want to do that. And you've got two sorts of memories that you're kind of dealing with here. So both of these enable you kind of auto learning of the system. So the first thing is whenever you serve an answer to the user or response to the user based on the natural language query, and you've got functioning SQL coming out the other side, you can make an assumption. The default assumption will be, yes, this is what the user wanted, in which case you're likely to go ahead and persist that into your database. Or of course, you've got a way for the to work out, okay, is it a thumbs down, or is the user interacting with me further saying that I've got something wrong, to work out whether or not you persist that. But the point is you've got essentially, as users use the system, you can dynamically build up this kind of history of natural language queries and what the valid SQL response was, and build upon that over time. And that's the same kind of thing for your domain knowledge as well. So yes, both of them, once again, are kind of stored in the vector database. So when you're going about setting this up for the first time, obviously you go ahead and seed it with your DDL. You go ahead and seed it with your business terminology, and you go ahead and seed it with a series of question and answer pairs of, this is the natural language query, this is what the resulting SQL that I provided was. And then, of course, as it goes over time, you examine the input which has been provided by the user, work out, okay, which context does it put in, assume success by default, unless you, of course, whether you've got a thumbs down, or go through the thing where the user seems to be arguing with the system to go ahead and work out whether to persist that or not. And that can obviously be done asynchronously, but that isn't, of course, necessarily a complete solution, but you can see how these things would naturally evolve over time. The thing is, though, of course, with this kind of system, success, there's pretty much just what I outlined there. The thing is, of course, the associated risks. You're not getting a clear idea of what that is. And so there's different ways to kind of manage this. And there's kind of stated here, whatever you put in, you get, garbage in, garbage out. And there's a couple of different ways to kind of facilitate this. And one of the things is with any of these type of systems or whatever else, ideally you've got, with any AI-based or generative AI-based application with a chat interface, you'll be wanting to have telemetry, which is capturing what the user requests are and being able to monitor, and then ideally being able to classify them later on. And you could see in this thing, for example, when a larger enterprise type customer or whatever else, where they've got a data and analytics team or whatever else, they'll be going ahead and having a look at these and saying, okay, based on what was passed through, was this a valid SQL query that was created or not? And so there's a couple of, some additional work which is required from a curation stage for that. But by default, as you can imagine, the success path might get you 80 or 90% of the time. And then if you want those really kind of high quality results, then you can work out, okay, am I persisting this or not? And what's my level of curation here? And so what that roughly looks like, we don't need to go into some of the more kind of sophisticated AI or generative AI type solutions where you've got something such as an encoder model or classifier at the start to go work out how to route this or what to do from there. But it all can be facilitated within the single prompt here that you're seeing up on your screen right now. And so, yes, basically we've got this thing that we've got the based on, okay, what's the user requesting? Are we doing a particular tool call? Are we persisting in memory? Are we executing a SQL or whatever else? And all this is facilitated in a prompt which roughly looks like what you've got up on screen there. Okay. So, yeah, we've understood what the general flow for this may look like. But the thing is, of course, SQL on your database. And this is one of the things that you often see with people who are just new to agentic coding or just working with these AI type systems. They assume, they say, okay, well, the LLM's smart enough to work it out. It shouldn't be dropping the database or anything like that. You are never going to solve this through a system prompt, just to be clear, or just begging it not to delete or drop or whatever your database, because obviously there's lots of different ways, whether it's through DDL or going through something like truncate table or whatever else. There's lots of kind of funny ways it can kind of mess with this thing, and depending on how it goes off the rails there. And so it all comes back to 101s here for a predominantly software development type basis here. Is, as stated before, we've kind of got this naive approach, which is just saying, please don't drop the database. We've got this other one, of course, if you're particularly technically savvy developer and you're deep into kind of meta languages, DSLs and going ahead and building abstract syntax trees, kind of deep into Lincoln expression, breaking things into expressions. That is also overkill in terms of parsing your SQL like that. And that only goes so far, because it will take a real kind of cost to, depending on the level of nesting and whatever else that you're dealing with there. That's quite a complicated endeavor. And so your kind of best approach, of course, is just kind of really much going back into the basics. And so around this, we're kind of talking about kind of classic database type permissions, making sure that you're only granting kind of query access. You're using potentially, row level access. You've got a schema defined, and you're also passing through user based on the user and doing user impersonation when accessing this. So my point is despite how wonderful LLMs may seem, the naive approach is definitely not the way to go. That problem will never really be solved. And it's not a criticism necessarily of the technology. It's just one of those fundamental things in terms of communication. When I'm speaking to you here now, I can't be sure that you've understood everything that I've said, and vice versa, or at least maybe the way that I intended it. It's not a reflection of the audience. It's a reflection of my mind being in my head, and you've got your own thoughts, which influence a thing. And as a result, the same kind of thing happens with the LLM. It is a different system. It is not embedded in your brain. It doesn't think the same way that you do. And no matter what you try and come up with, these systems will never be smart enough to kind of work out these things. They'll work out something within reason, but it's whether it's purely programmatic or procedural from its perspective, or something which is character and it's got some sort of intelligence there sitting in the background. That alignment is always going to be, it's not ever going to be fully aligned with you. So as a result, you want to go down this route whenever you're kind of working with these systems and kind of mission critical, something which is really important. You need to have these kind of safeguards in place there. And so database level is definitely a good way to go for this. I'm just going to go on a slight tangent here. For example, if you're doing PII removal, you're going to be using something which is one of these encoding type models that I mentioned before, as opposed to a decoder, which a large language model is. And what that's got the ability to do is classify certain pieces of information and essentially provide a yes/no answer to that. And so one of the kind of common ones that you might use in, for example, for PII is something called Microsoft Presidio. It uses space in the background, but though you've got different ways to go ahead and do this. And that's a model which can run locally or run within a Docker container and go ahead and identify particular types of information and substitute those. So if you really want to go full down the route and say, okay, we've got a local model and we just don't want anything at all. So you've got the ability to go ahead and go through named entity recognition to go ahead and identify that these are what these values are relating to. So the thing is, it's still putting together the query. Hopefully it's relatively harmless to say how the customer is X or whatever else, but obviously there's ways to kind of anonymize that as well. You build up a dictionary. Sorry, I'm probably going a little bit too technical. You can go ahead and build up a dictionary for the terms that you want to go ahead and take out of the prompt, substitute them in with another kind of term, get the result back, and then substitute those values back. From an SQL execution perspective, the actual SQL results don't actually have to go back by the LLM. I realize that might not be a complete answer, but it is a solvable problem following roughly what I outlined there. So with this, in this particular flow here, we're just looking at the LLM to generate the SQL, not to parse the results. So as a result, that typically isn't necessary. There may be cases where you're working with MCP or trying to parse the results and saying, okay, now find the most relevant, which is not available in the queries, using some other terminology, which is a bit more advanced situation, but there's other concerns to be had there. Okay. So a couple of things. So around this, and it's quite popular by blog posts and Anthropic, or some research that Anthropic's been doing, and kind of the way that they're going in general in terms of this concept of a code sandbox to go ahead and essentially execute arbitrary code to go ahead and fulfill a particular request. The thing is hopefully, or know, at least for those who've done front-end development or whatever else, what a bad idea necessarily calling eval is on an arbitrary expression. And so that is one way that you can achieve it, but I'd recommend strongly against it. Instead, the type of approach that we'll be taking for this is essentially parameter extraction for this. So what we're essentially looking at here, and this is working around presentation, which I'll go into shortly, is we've got our results back, and then we actually want to go ahead and present that as a chart or whatever else to the user. So sorry, I realize there's a little bit of a leap here because of a question that came up. But in short, we've got our results, and now we want to actually go ahead and present them to the user, not necessarily just in a table, but perhaps as a single scalar value, or perhaps as a chart or whatever else there. And so, yeah, this is a little bit of a slippery slope. I won't kind of delve too much on this. LLMs are quite capable. They can do visualizations depending on the model that you're working with, but this is how you kind of build it from the basic building blocks without having any of those dependencies. And so for that particular situation there, you're looking at going ahead and saying, okay, we're going to have some sort of charting software running. In this case, I'm going to be using Plotly, but as you can imagine, there's multiple ways to do this. You could go ahead and feed the results directly through to your front end and call a JavaScript charting library, or you can kind of do the server side. I'll be doing the server side for this particular example here. And basically the idea is rather than spinning up in a different coding sandbox to go ahead and essentially issue arbitrary queries, all I'm really doing is saying, okay, here's the data that's coming in. I'm going to do parameter extraction, and we're going to have a function which is defined to be able to identify which type of chart we want and essentially render that chart. So there's a whole other thing in terms of if you go the full agentic route, but that's not the primary topic for tonight. We're looking for the kind of reliability here. And the type of audience that this is kind of aimed for is someone kind of using from a chat interface who's not necessarily deeply familiar with LLMs and how to kind of get these kind of results there. It's more so, I've got a simple query, I just want to see what the chart is. I'm not familiar with prompt engineering, I'm not familiar with code sandboxes, I'm not familiar with how to kind of massage it into what I want. I just kind of want these results. I want a simple chart that does this or that, or at the table, as it were. So that covers that topic. Once again, we've kind of got this concept in terms of what some of the pseudocode might look like to get kind of user-aware security. So once again, if you're using any sort of mature database platform, it's got a degree of some sort of permissioning system on it. And one of the key things is to be able to basically extract that identity when they're actually issuing the request. And then hopefully you've got your database set up so I can actually work through that rather than just working through a generic admin type user account for that. That's obviously a path to failure where you've got full access to mutations and everyone's got the same level of access, because realistically, some of the people engaging this aren't necessarily going to have the same permissions or access to the same parts of the schema as others here. Okay, so great. Kind of touching back on that topic again about visualizations and whatnot. Yeah, we need to now make it useful. So we're pulling back a whole lot of useful data, hopefully, and we've got to work out how we want to present that to our users. And so this is the thing, is we've got some relatively simple logic here to achieve this, and there will be a demo at the end here to kind of walk through this and explain how all this kind of strings together. But as I stated before, there's essentially kind of three types of data that we want to kind of, well, three formats of data that we want to kind of represent to the customer, or sorry, to the end user. One of them, of course, is a simple scalar value. So that's where you're looking at aggregating a whole lot of values and producing a single value. We've got this other one where you're kind of typically dealing with small kind of tabular data. So think of something like key value pairs or whatever else, or saying, okay, this month, this is the revenue, etc. And then we've kind of got this other kind of situation here where we need to kind of see some kind of visuals because we want to go ahead and present that in one way or another. So in this particular thing, we were dealing with a chat interface. For example, we're just saying using something like Microsoft Teams or whatever else. So adaptive cards have been around for a long time, since about 2016, 2017-ish, if I remember when I first started working with them. And the idea is basically you need to somehow get this output that this function that you've called, which generates the plot, to go ahead and present it within a chat interface. And this is one that, depending which agentic framework you're working with, they do obviously have different options. This one is predominantly in the Microsoft space I'm talking about, and using the adaptive card technology, which I'll demonstrate shortly. And so this is kind of the third option here around the kind of chart card. And as you can imagine, there's different things for this. Once again, for this demonstration, I'll be mostly using Python, but it does apply across different languages based on the charting libraries and whatever else. The concept should remain roughly the same depending, which environment that you're working within. And so what we end up with is this complete flow here where we've got the resolving the user, we've got our RAG retrieval, we're building the prompt, we've got the LLM core, We're extracting and validating the SQL. We're checking the parameters and executing. We're streaming a response and then saving it to memory, assuming it's a successful response there. And so, yes, as pointed out before, we want identity to kind of flow through for every step here. So I've spoken about a whole lot of different topics. It's maybe it's kind of very loosely defined in your head in terms of what all these pieces look like. And yeah, perhaps you want to see what these different pieces may look like working together. I've got two variants of this. I've got one running locally and one running on the cloud. So I'm going to give the cloud one a attempt first. I'm tethered. In theory, it should just work. If not, I'll swap across to the other one. So I'm going to pop into the demo now. And I will make this a little bit bigger. So what I'm using here is a framework called Vanna, at least an older iteration of it. Oh, sorry, this is the local one. I'll try the internet-enabled one. And basically, all that's done here is in the earlier iteration, a lot of this kind of came out of the box for you. Obviously, other frameworks have different ways of achieving this, but the point is that all the building blocks that I've shown you, you should see how they kind of work together. Now that you understand the prompts work, how the individual components work, you can implement this agnostically in any framework. Okay, so I've done this. I'm running on Mac here. Just going to go through this in Python. I realize a lot of you, just give me a minute. So I'm going to have to do this differently. I'll just do this in Jupyter. I'm going to drag this window across. It's always the thing with demos. There's always something that you don't necessarily anticipate, but it's all right. We've got ways to deal with that problem. Okay, so I'll do it from here, and hopefully I should be able to bring this up. And what I'm going to do is show all these kind of components and then give an idea. So I'm not going to embed it for, into Teams, whatever in this particular process here. If you want to do something like that, you'll be using something like the Microsoft framework, quite a mature platform, been out for a while. It's just with some of the things around streaming and setting your own Teams instance. I didn't want to go to that degree for this presentation today, but I will show all the individual building blocks and what they look like. Once again, this one is done in Python. It doesn't really matter which library you could do, or which language you're using this in. You could do it in .NET just as easily. It's just typically I do a lot of work, my work in Python with a lot of the AI and ML stuff I do, but yeah, hopefully it should remain relatively consistent. And yeah, to be clear, there's a couple of things that I'm doing here. So first of all, I just make sure that I've got Docker up and running. And where you all. Okay, so I'll stop that and spin this one up. Okay, so first couple of things, not necessarily too exciting here. We're just loading variables here. So I'm using Azure for this. So kind of typical things around API key, the endpoint. I've got a couple of things around the SQL connection string. So once again, I realize not everyone here is going to be familiar with Python, but hopefully it's relatively clear what's going on here. It's an empty environment. Going to hopefully be able to populate the database. That will be a little bit embarrassing if that falls over, but we'll see how we go. And for this, there's a couple of things that I'm using just kind of very quickly here in terms of, okay, what are these different components? So in this particular demo, I realize you can't necessarily see this. Oh, I can make Docker bigger. Okay, that's great. I'm using a Mac. I'm using SQL Edge. I realize it's retired now, but hopefully it should demonstrate proof of concept here. Just think of this could be Azure SQL or SQL Developer Edition or Postgres or whatever else. And the thing is here for what I'm doing for the rest, I'm using Azurite for my blob storage, which is going to be storing the charts. Once again, essentially technology agnostic.
Which SQL server is in about?
SQL Edge. Once again, I'm aware that it's been retired or whatever else. It was available up until somewhere end of 2025.
So it's the old stack instead of file.
Okay. Once again, it's just the Python ecosystem. RE is regular expressions, a couple of things around shell and ODBC. Once again, not to get too caught up on there. For this, for the vector store, I'm actually using ChromaDB, but obviously it could be Pinecone, it could be Postgres, it could be a whole lot of other different platforms, or if you're going down that particular route, you could be using something like Cosmos or whatever else here. That's pretty much irrelevant. And so basically what I'm doing here is just going, so it's not necessarily too exciting here, just making sure I'm creating an AdventureWorks database, which is one of the classic ones from Microsoft here. I'm going to issue a couple of queries against that. As mentioned before, I'm actually using the vanilla library, but I've just gone through what that pretty much entails here. For this demo, I'll be using GPT-5 Mini. It's quite sufficient for my task. Once again, if this falls to the internet demo, I'll just revert to LM Studio locally. Just testing our connection. Okay, so I'm connecting to my instance locally, which is good. And this is what I was talking about before. So these are the three things that I'm priming with. So this one's relatively kind of simple schema. We've got a series of tables here. So this is the DDL for this small database. So product category, customer, product, sale order detail, those kind of things there. So these are the DDL statements. So just purely going in as a string. And what I'll be doing is for each statement within here, in this case, it's calling the train, but all that's doing is these are being embedded and put within the ChromaDB store. So we're adding this, just simple output there. We've got 5 DDL statements which are going into the vector store. Got the same kind of thing here, and this is the example that we've got AdventureWorks. So this is where we're going on to that earlier slide where I was talking about embedding the domain knowledge. And so we've got the documentation here, sample database, key tables, relationships, revenue, but you could imagine we can start adding additional features to this. Once again, this is a relatively small pet demo here. And then the third part, so if you remember those 3 blocks, so first one was the DDL, so data definition language. The second one was kind of how these things kind of relate. And the third one is some sample kind of queries that we've got here. So what is the total revenue? Show product category, categories, etc. But hopefully the general gist is clear. So this is the third part that we're actually adding to the store. Okay, you can see it's super quick in terms of what I'm working with here. And then this is where we kind of go through the basics here. So one thing is in Python, I've got a really easy way to kind of display some of this information here. So I've got a couple of things around formatting, and I just want to make sure I format these things correctly. And this output here is quite verbose, but you're getting an idea. You're going to see the same prompt that I kind of demonstrated earlier. So you're a 2 SQL Microsoft SQL Server expert. Please help generate SQL query to answer the following question. Your response should only be based on the given context and follow guidelines and format instructions. Once again, apologies for the wrapping. This is just debug information here. We've got the tables, which once again is, you can see here, the DDL, which I fed in earlier. So you can see how this is all being retrieved and put together. And then we've got a little bit of noise here. Then we've got a couple of things here around key tables. So this is the what we're kind of talking about before. So this here corresponds to the business context. And then we've got some other details here. And so what we've got the initial response that the LLM came back with. It's generated this, and then when we actually issue that response, we get the value here, which is $956,000. So that's getting a scalar value. Same kind of thing here for tabular data. Same kind of thing. You can see it's the same prompt going over and over here. And in this case, we're actually getting back our tabular type results. And so for this particular query here, I'll just pop back on this. Show products in the bikes category with their prices. Once again, this is all just debug type information here. We've got the response where it's got the selecting of the product category and what the list price is. You can see here, I probably need to make a small adjustment here for the list price because I'm not formatting the currencies correctly here, but it's just stored as a number within the database. But once again, that's easy enough onto the question that you raised earlier in terms of formatting the output when it comes out. So knowing that the schema should be represented as a dollar value or whatever else. And then finally, we've got perhaps one of the more interesting ones is, okay, might need to run this one twice. Show a chart of revenue by product category. So once again, we've got this, and we're going to see what the result is. And then, we've got the response. So grouping by category, we've got a series of froms, joins, group bys, or whatever, since we're grouping by product category. And we've got what our table looks like here. And so the thing is this is demonstrating back earlier in the when I was talking about getting these visualizations, we've got the data back. We've got it in a tabular format, which we're all kind of familiar with when we're working in this particular space. And then we've got a function here from Chart Exporter, which is just something I've got in here. This is where I'm kind of doing that using Plotly, but you could imagine it would be D3GIS or whatever other kind of visualization tool that you're using for this to go ahead, which takes the parameters or the data frame in this case. So this is data frame in this case is your table. Keep providing a title, a chart type, and then going ahead and saying, okay, is it a pie, a line, or a bar chart? So you can see the different kind of visualizations that we're getting here. And then we're basically rendering that table based on whatever it looks like for that charting library. So I want to kind of pop back here. For the chart exporter, we've got detecting the chart. And then we've got this kind of thing here. We've got this function export chart to PNG. So you kind of see how these things are coming together now. So the LLM's job is finished here, just at this previous stage in terms of LLM just generated the SQL call, the SQL statement. We've taken that SQL statement, called the database, got the results back. So whether that's, depending on obviously which library that you're using for that, you've got that. Then you're feeding those results, whatever format that you want, JSON, CSV, whatever else into your charting library. And then we're going to go and generate that chart. And then we've got that as a PNG here. So what we've converted is this particular table here. And now we've got those values here. And you can see based on whatever I wanted to do for the chart here, we've got those results. So I realize this is all in the notebook. It's just the easiest way for me to demonstrate as opposed to going through it down the full route. But as you can probably appreciate, what export chart to PNG means is that I now have got a artifact of this, which I can store somewhere. So this is where the Azurite part comes into place, because I'm using blob storage, which is quite common in the Azure space for storing essentially arbitrary data like this. And so what we're going to do now is basically we've got a connection string to our blob storage, which I showed before in Docker. So this is the Azurite instance here. And we've got the chart size and we've got a chart URL. And so now this here, I'll just try and make, it's going to be a bit hard because I can't really zoom the address bar. It's localhost running on 10,000. We've got the dev store account 1, which is a typical thing when you're working with the Azurite. We've got the chart, we've got the PNG, and it's stored within the PNG. So now I've got an image I can export to someone, copy, whatever else. As you can imagine, within an application, it's up to you how you serve that. So now that we've proved the image, you can imagine that, and we've got a URL to that image, which hopefully we're kind of seeing here. Then obviously I can embed that within my application or whatever kind of environment it is to go ahead and pull that, assuming that, whether it's sitting in Azure or it's sitting locally on a, whatever kind of service you're working with there. So that's great. We've got the chart. Now what we want to do is embed that chart within a chat interface. And the one that we're going to be using here is what I mentioned before, is talking about adaptive cards. And so we've got a simple adaptive card here. We've got, we build that step by step with a series of text blocks. It's a bit crude in terms of how I've done it. If you're doing this in an actual environment, you'd obviously have this kind of defined as a separate file rather than having this kind of else if kind of logic here. You'd separate this neater and then just do template substitution. But the premise should be relatively clear in terms of what we're doing here. So we're using the adaptive chart library, which is also available from for Python, but obviously .NET and a lot of other environments here. And then we're going to go ahead and we've got a thing to display that. So what that looks like, we're going to create some of these. So we've got a text card, so I can embed this directly within Teams. We've got a text response, and this is where we're talking about those kind of scalar values. Where we've got a summary. And so this is the thing for Teams design, and this is what that would actually look like. Same kind of thing. We've got, okay, this time we're going to demonstrate what a table looks like. Same kind of thing. This is all within an adaptive card. And because I've got full control over this, you can kind of see this kind of interface that I'm getting. So that's going to be coming through Teams, Slack, or website, whatever you're working with. And then finally, we've got this one here for the chart card. I didn't modify all of these, but to give you an idea, we've got a chart here. I've decided to be a little bit more creative with this one. We've got the chart, we've got the whatever functions we've got in our charting client-side or server-side charting software here. We've got the table that we can kind of navigate through. And because this is all in blob storage, you're not going to be able to see this URL at the bottom there. I've just simply added a button so I can go ahead and download that CSV here. So what I'll do, I'll bring this up in numbers. Apologies because I don't have Excel as a first-class citizen on this laptop. But hopefully it's relatively clear what's going on there. So if I can't really bring that bigger. That's once again something better. Yes, okay, zoom. We'll just make that 300%, and you get the idea. So I've downloaded that CSV. You can just display it in Excel or whatever kind of format that you want there. So what this enables us to do, as you can imagine, is now we've got access to, we've got a visualization, we've got the chart, and of course the missing step is, and this is one thing which I haven't kind of covered earlier, but it's just for clarity here, and I'm going to touch on it briefly later as well. So we've got like the full flow. We've got a process here. This is demonstrating the full end-to-end pipeline here. The data frame, and then we've got some contest questions to kind of run this against to see what it looks like there. This will take a minute or two. And what is the total revenue? It's processing that. We've got a scalar response here. Show products in the bikes category with their prices. Once again, we're seeing all the what's done there. We've got a table response there. You can download the CSV. Show a chart of revenue by product category. And this one should be coming back in a minute. And there we go there. And once again, the classic adaptive card there. So You can see we're getting pretty far along with this now. So I can embed that in chat, embed that wherever else, got the source data stored in blob storage, whatever that may look like. And then of course, the other thing is we've got the SQL generator, we've got observability, we're tracking that in the background there. And the other thing that you can do for the user, of course, is, okay, maybe it's an ad hoc query that they're issuing through the chat interface. What you would do in this type of situation, I'm not going to demonstrate it here because I don't have the full chat interface working, but I've got all the individual components, is you'd actually have an explanation. And when you're working with things such as Claude Web or the GPT, they've obviously got this thing where you can kind of expand on the thoughts to see what process it's going through. In this particular case here, if you're delivering this to your organization or a client or whatever else, you would just probably expose that SQL directly, and so they can go, okay, now to go to the data analytics team or go to wherever else, can you verify this? I want this put up in this different format here. So as you can see with this, you can do ad hoc queries relatively quickly, but depending on how much effort you put into your kind of chart libraries, you could actually start generating potential non-interactive charts, but obviously depending on the charting software, you can also start going down the kind of dashboard route as well, that people are able to do this relatively quickly. So it might be something suitable for a report or whatever else that may look like, or just simply for a PowerPoint slide. We've got this concept of workflows, dynamic and LLM versus agents. You can go down the full agentic route here. That's usually for more power users who are really familiar with working with maybe Claude Code directly or going down these particular routes here. That's not for this audience, but both options are valid. What that actually looks like moving forward is you've got some issues here as well in terms of how complicated that you make this. You don't want to usually use too many tools for this thing, so we try to keep this relatively simple. And probably the big thing here, and this is where we've got a bit of room for kind of talking, is, what do we want to use dashboards for? And this is a kind of classic question for people working in the data analytics space. There's some things where you need some of those things from a governance perspective, making sure they meet regulatory requirements and whatever else for some of these visualizations. But for a lot of other things, you can actually just use natural language queries to kind of fulfill a lot of these kind of ad hoc criteria or some things that people need to kind of walk the board every month to see what things look like. Some questions, I guess, just things to think about. I won't dwell on this too long, but feel free to ask questions afterwards. What's the future of data analytics teams? It's probably going to be something somewhere in the middle there. There might be, instead of working all day, every day in Power BI, putting these things together, they may be just using natural language queries, or they might be just curating the list or making sure that these patterns are matching well. Can be able to chat over everything. This pattern I've only touched on data analytics, but as you can imagine, it applies to APIs and a whole lot of other things like that, where you've got data embedded within an operational database within an app with an API, but that's a topic for another session. This kind of provides you intent over interface. So rather than having to kind of click through or drill through 50 different things to get the data that you want and kind of put in these queries, you can just say what you want. That's kind of a general trend that we're seeing these days in terms of how people are interacting with these things. Got this concept of SaaS products are under a lot of threat, and Power BI might be under a bit of threat as well. So Microsoft may actually be cannibalizing their own market with this kind of functionality here. And this is, the kind of case in point is something like Figma, where basically it was valued at $60 billion at one point, but essentially what Figma does can be reduced to a 10-word prompt, which is a pretty painful thing to hear. The point is you need to be kind of aware of these tools, what they can kind of do, and hopefully this demonstrates a bit of proof of concept of that. So yes, that's it. Got the outline there, and if you want to know more, ask some questions, feel free to reach out. I'm happy to hook up, but do feel free to connect with me on LinkedIn, and if you've got any questions or trying to solve these problems in general, let me know. But always happy for a chat, and pick up on things. Thanks everyone.
But I do have one question for you before we move to the audience. Have you tried to integrate MCPs, for instance, to run the SQL query?
Yes, there's lots of different ways to implement this. I went with a very kind of vanilla case here. MCPs can be a little bit hit and miss. There's more of a push towards skills these days, and a lot of things that you would have been kind of allude to it earlier about being able to kind of do things in process as opposed to kind of dealing with some of the kind of potential latency issues there as well. So the thing is when you're using MCP, that's going to be hosted on a different server. You've got round trip time and other kind of considerations there to kind of take into account too. So it just depends on what your constraints are, but simple architecture can often take you a long way.
Yeah, also a bit repose on the turn on.
And I'll just make one comment to what you said before about safe for now. one of the things, interestingly enough, is there's plenty of we're in a time of a lot of change right now. The thing is if any of you got any kids or whatever else who are going through school right now or university or just may have finished up recently yourself, this thing is going to be pretty much referred to as table stakes for the next 5 to 10 years or whatever else. A lot of people will be very familiar with using these tools. I've got 3 children myself. Eldest is in grade 2. By the time she's through school and university, a lot of this will be taken for granted with the way that these things mature. So definitely safe for now, as you say, and definitely need the expertise to go ahead and implement these things and get it laid out. But things are always changing, right?
Yeah, it's very magical when you know there's something wrong in the database. You roughly know where it is. You roughly know how it looks like, and you ask AI, "Hey, can you find that thing?" And it somehow finds it. That moment is magic. The first time that happens, like, oh, this actually works.
And I guess to your point as well around expertise, that's part of the reason why we feed in the business context, because the domain modeling, you're always going to have that mismatch, right? And so you need someone who has the knowledge of what the data structures look like, what they're meant to represent to be able to do this effectively.
All right. So let's try to get some questions from the audience. Do we have any questions? No question? Do we not? Yeah, turn it on.
Oh, okay. So my question is that, from what I just saw, it's like converting a natural language into some sort of SQL query. So like, what if the user like asks something very complicated? So the large language model is not capable of converting that question into SQL query. So instead it just like come up with some random query. So it would just like provide some like nonsense or something completely different or inaccurate data to the user. So like, then how the user would know, oh, it's not correctly answered to my question?
So this is a good question that applies to large language models in general. The thing is you can't necessarily let it go completely autonomous, and this is part of the alignment issue that I mentioned before. One of the benefits of these kind of things, as far as structured language goes, that there's some things that they're very good at doing. You're going to have a very high probability of success. And the thing is for the most part, it's a case of going to be how you frame it as well. There's going to be a lot of kind of common queries you're going to be able to surface very, very easily. There's going to be some of these more kind of sophisticated scenarios where it's ambiguous there. So obviously things to determine whether or not it's valid SQL. And there's a lot of other kind of side effects that you get with that as well. Like it's going to be providing the wrong results, or the numbers are going to be looking completely off. And a lot of people have a default kind of intuition for that, saying, okay, this is off by a factor of 10 or whatever else there. And this kind of ties into that explainability theme as well that I just only briefly touched on, is where you kind of got this thought process and you say, okay, well, this is the actual query to see what it actually went through. So if you're kind of genuinely interested in this, you go ahead and say, okay, listen, give it to a dev or someone working in the data and analytics team to have a look at. This is what it came up with or whatever. Because you can imagine this kind of thing, a lot of general questions that saying, okay, what were the sales for this month and things like that are very common questions that make up a good 80 or 90% of what people are looking for. And these other ones, if you find that, okay, you're running into these all the time, typically you'll be somewhat aware of that as a business, and it'll be part of what you've gone into kind of prime your database with. So what I mean by is those simple questions and answers and whatever else there. But you're quite right, it's never going to be 100% right, but that's also only kind of typically happens in those cases are becoming more and more niche. And the big thing about any kind of LLM implementation where you're kind of getting these responses, and it doesn't matter what the context is, not just data, is to actually have that kind of explainability piece. So someone can go ahead and say, you've got 2 things. One, if you've got it stored in your observability platform to say, okay, you've got to use a complaint or whatever else. We're going to have a look at this and try and correct it. And because you've kind of got this adapting system there, you can correct it fairly easily without kind of interrupting the flow. And similarly, once again, you've got the query there and say, okay, I want this done. You can copy it. You've got direct traceability to use this empowered to be able to do that and then pass it on to someone else. So there's still got to be this kind of human in the loop. But as you can imagine, for most cases, things, okay, what were the sales? What are the things by quarter? All these kind of typical kind of questions will be fulfilled by a system like this.
Okay, so like, because like you are asking the question, you generally have a like rough estimate of like what would be the answer.
Yeah. I think that would generally be it. If you're going down this kind of other route, with a kind of more exploratory route, that's where you might be going down. The thing is there can be a little bit of resistance in terms of trying to work out and express yourself clearly or whatever else, because the fact is, if you can't express it clearly, then chances are the LLM may not be able to understand it clearly. So that seems to be a reasonable expectation there. And there are also kind of other flows to kind of explore that, because if you're going down that route or whatever else, where you're doing that sophisticated thing, you've probably got a mind which kind of works towards that degree of complexity anyway. I realize that might sound like a little bit of a leap. The way you're kind of thinking about things and saying this, but not that, you'll be generally vested and interested in what the result is. And so in that case, you've got that explainability there. So I realize that doesn't quite answer the question, but it gives you an idea of how many cases that we're kind of fulfilling with this kind of solution here.
Yeah, thank you.
Because a lot of these things, unless you're going 10 levels deep or whatever else, then yeah.
Good.
Sorry, this is a bit of a naive question, so bear with me. But in terms of your recoverability, so if these ask a question that it can't translate to SQL, or it runs into some form of roadblock with a permission or security problem, when I was looking through your code, I didn't really see much user recovery or handling of errors. So how would you sort of circumvent that, or can you expand a little on how one would present user errors or recovery processes?
Sure. Okay. So that's the thing. I didn't want to go down the entire route. However, to cover some of these things there. So from a permissions perspective, yes, you would put appropriate code boundaries within that. So the thing is once again, like I realize part of it's going to be, of course, how you configure your database, and depending on what kind of errors, like particular errors that you're getting from the database, that's fairly easy to service. And the thing is that kind of situation there, you'd imagine there'll be well, depending on the situation, like if it's internal, then you can obviously manage that and say, okay, so-and-so needs permissions to this. Hopefully you've set up your groups correctly and whatever else from that perspective. Now, from a recovery perspective as well, a lot of these things, so for example, if you're using OpenAI or whatever else, they've got retry with exponential backoff built into the system with 3 retries by default, I think it is off the top of my head. But you can kind of also configure that. And so when we're kind of dealing with these things, it's typically often the same way they're kind of surfacing these things in web applications as well. Like it can obviously be a bit neater and better than thing, catch the error, say, okay, if you're working with structured output and it's not producing SQL or it's timing out or whatever else, going ahead and servicing that appropriately. So I realize it's a bit of a generic answer, but the thing is once you've got the kind of core building blocks, then you need to start kind of putting these different things there and there around, retries, doing that asynchronously. If it can't surface it at all, you can bounce that back to the user. And there's obviously, it's a kind of typical thing in terms of triaging.
Because building up his question earlier, I had that similar sort of concern of if it can't find an actual answer, it just starts making things up, because I'm sure everyone's gone through hallucination at some point or another, and not really that fun to deal with.
Yeah, so
especially if you don't know what you're looking at.
So that's the thing. If you want to go further down that route, and that's a big concern there are certain evaluations that you can kind of do to go ahead and value that the accuracy and whatever else, so in terms of when you're actually putting this together, but more so going down the route. And it's just a case of what degree that you need to go to for this in terms of how common or uncommon that is. So it's just like a lot of kind of recovery situations in terms of, okay, is there a right to have, what's your SLA look like from how many nines or whatever. But for that particular situation there where you're saying, okay, we really want to kind of avoid that, then you'll probably be going down a route where you've got evals run on every request. And what I mean by that is going through and passing through either LLM as a judge or an encoder-based model to go ahead and say, okay, is this response grounded in this, and having that kind of third-party evaluation. And then, of course, if you want to go to the next level for that, just to be clear, to be real specific here, you need to use a different model to the original model that put up with it, because otherwise it'll be go down a similar kind of thought process, despite having different seed and temperature settings. And then if you want to go kind of further down that route, of course, you can kind of set up a quorum for that as well, after which stage you could, there's only so far that you can kind of go for that. So it's just a really case of how many nines and then how much latency you can kind of put up for this. And once again, it just depends on what a lot of your common use cases are. And just like with delivering kind of any kind of solution like this, you've spoken to your end user for the most part, you've got a fairly good understanding, you get that very good kind of coverage in terms of what you're trying to achieve, rather than just working in isolation there. So a lot of those things can be addressed by that. And of course, kind of tying into that kind of thing around curation, observability as well. Depending on which observability platform you're working with, you can kind of look through the different responses there, but you can also have automated eval sitting on that depending on what you're working with too. And so, judging that. And so maybe a little bit of delay before the responses come through, but there are different ways to address these problems.
Thank you.
There you go.
Hello, Jack. Great demo, by the way. In your code and in your architecture, I didn't see any filters. So, for example, I can control the backend visibility of the data using row-level security. The database user will not allow me to delete things, which is great, which is fantastic. If I implement this into an organization, and if I'm the electronics executives,
Mhm.
and the organization doesn't want me to see the profit of the clothing executives in the clothing department, how do I filter the questions in this so that I'm only allowed to ask my relevant questions and not off the clothing department? So from the front end.
Okay, so that's a good question. That's going into some fairly sophisticated scenarios here. I've run into the same kind of thing when trying to do something for a SaaS and for the multi clients as well. You can actually, based on, so typically you break these things into roles as opposed to individuals. That's kind of fairly good practice in terms of what you're looking to do. And based on that, you can go ahead and set up a different partition or index based on those type of roles, what that precedent looks like, and then that ties into your database behind. Just once again, all these problems are solvable. I didn't want to go too deep into every single detail, but that's roughly how you go ahead and solve it. So essentially, you have an index per role with these kind of pairing, with the for those kind of combination sample queries, the scheme which is exposed to them and whatever else, and then you kind of dynamically swap that out, routed based on what the user identity that you're receiving is.
So when you say no, or by RBAC it can happen, or by no lens like user that asking the question.
So that depends on the organization, how well structured your database and how consistent that is. I can't provide a specific answer because that would be case by case, but the general theory is roughly that partition based on expectations there, and obviously have your database in line with that.
Do we have any other questions? We go 3, 2, 1, fold.
Okay. Thanks, everyone.